All right, we'll go ahead and get started. First of all, welcome everyone to our webinar, our November webinar. For those of you who are in the United States, a happy belated Thanksgiving, and looking forward to the rest of the holiday season for everyone. So we're here to talk about IEC 62443 or ISA 62443 standard. This is obviously a very hot topic. As evidenced by the number of respondents we had to this webinar. I think it's by far our largest webinar attendance. And I'd love to say it's about me, but I think it's about the topic. We do one of these every month. And the next one, we're actually going to dive into the governance topic. That seemed to come up with a lot of the questions in regards to this webinar around governance and organization. So we're going to try and do kind of a deep dive in our December webinar on that topic. But anyway, on to today's show, so to speak. So just by way of introduction, I'm John Livingston. I'm the CEO of Verve Industrial. I'll tell you a little bit about us in a second here. I spent about 20 years of my career with a firm called McKinsey & Company. It's a large global consulting firm where I was a senior partner there, helping lead a lot of these business digital transformations across industrial sectors, leveraging wireless technologies and a bunch of other things. I've been at Verve for a little over 5 years, helping drive the implementation of OT cybersecurity, as that was one of the biggest challenges we found in doing those transformations. Along with me today is Ryan Zahn. Ryan is our Director of Customer Success. He's been in the ICS security world for about 15 years. And prior to that, he was an EMS engineer. He's going to be taking us through a very brief demonstration today, later on in the presentation here. A bit of background on who we are and how we come at this topic. So Verve has been around for almost 30 years. It was founded as an OT or ICS systems integration and automation firm, helping clients design control systems, et cetera. And then about 15 years ago, in large part originally through the introduction of NERC CIP in the power sector, our clients began to ask the firm to help secure the systems that they had designed. And so we developed the first version of what we call the Verve Security Center, which is a vendor agnostic ICS security platform. Our team is very much control systems focused, right? Most of our team is our control system engineers, and then we've blended that with a range of IT folks, particularly in our software development. And as it comes to the standards, we've had various folks from our team involved with ISA for a long time. And then here recently, we've been doing a lot more work around assessments, leveraging the IEC framework, and then helping people mature their programs. And as we do this, a lot of times we get started with a client that's been trying to do this for a period of time and struggling with some of the challenges. And so what we're going to try and talk about today is the basics, try and introduce people to the basics of the various topics in IEC 62443, but then talk about practically how you can start to make progress. So for today's discussion, certainly 62443 is growing in usage. I think just evidenced by the number of people in attendance today, it is clearly a standard which is being broadly adopted. And it does provide a very broad, comprehensive, risk-based approach. And so there's a lot to be said for the standard. However, at the same time, there are a number of practical realities. As I mentioned before, we work with a lot of clients who have gotten started, and it's challenging, right? There's a lot of materials. There's a lot of depth and complexity to the standards. And so what we found is by taking an application of technology to this and using that technology to enable you to get the kind of visibility and actionability in your control systems networks, allows you to move more quickly and allows you to kind of do a walk run type. We don't like to say crawl, walk, run. No one likes to crawl. So the walk, run, sprint mentality to achieving the overall maturity against the standards. And then we're going to talk a little bit about we're going to show about demonstration of how monitoring the security levels achieved in the IEC vernacular versus the targeted in different zones can come to life and how that technology can be leveraged to streamline the overall process. So to start with, one of the questions we got about 40 or 50 questions prior to the webinar today, so we'll probably try and touch on some of those as we go today, as well as answer any that you put in the Q&A here live. But one of the questions was around how widespread is IEC 62443? How many people are using it? Well, one data set here is the SANS ICS survey that they do every 2 years. And I think it's interesting to show the trends here over the last roughly 6 years. And what you see from this is the NIST cybersecurity framework is still the dominant framework being used. What we're seeing a lot of, at least in the clients that we work with, is blending of these, combining NIST with certain elements of 62443 where it makes sense. As you can see, other standards have declined a little bit, like the CIS Top 20, NERC-CIP a little bit. I think in large part that's probably due to a broader group of industries coming into the world of ICS security rather than just the North American power sector. And as you see, IEC 62443 is growing. What's not on this page is all of the local or industry regulations that are present out there beyond the NERC-CIP topic around the world. But the short answer is IEC is a growing and very prevalent standard in use today. One of the other questions was, well, okay, but how does that relate to the Purdue model? You know, we've been working on the Purdue model for a while, or our vendors are suggesting, you know, implementing parts of that, or you know, maybe these things are related. Anyway, just wanted to kind of lay some foundation here, and we're not going to spend a lot of time on the Purdue model. But one of the challenges is we take models that were designed for one purpose and we try and adapt them to other things. And I think one of the advantages of the IEC structure is it is focused on security. And so the notion of zones and conduits, et cetera, is a risk-based security approach to it. Whereas Purdue was not designed for security. And so while it has some advantages from a security point of view, it wasn't specifically designed for that. It wasn't designed for risks and threats and consequences, et cetera. It doesn't necessarily, by executing, it doesn't necessarily balance spend against the biggest security risks. You can spend a lot of money trying to make the Purdue model work and not necessarily being spent on the most efficient way of securing your environment. And then there's other challenges with it. So we're not going to spend a lot of time on Purdue, but I think the point is that IEC is a different standard. It is a more security focused standard, and one that has a lot of advantages relative to the older Purdue model. So what is it? And again, we are trying to do a higher level, you know, we got an hour here. You could spend weeks going on doing 62443 webinars, but in short, so to speak, the alphabet soup, there are a lot of terms of art here, but to try and break it down to some of the fundamentals, zones and conduits, it begins with this concept of zones and conduits. Zones are essentially groups of cyber assets based on the function they provide with that have a similar security risk that need to communicate with one another, right? And then the conduits are essentially the groups of communications between two zones, based again on similar security requirements. Again, there's a lot more that we could go into on zones and conduits. This is a very high level description, but the basic concept is groups of cyber assets that are performing functions that need to talk with one another, and then conduits being the way those devices communicate, those zones, sorry, communicate. The next area is once you've defined those zones and your conduits, then it's deciding on what are the security levels that you have today. What are the security level actuals? What are the targets? So what is your security level target that you have? And then finally, what are the capabilities of that cyber asset or that system to be secured? So for instance, there may not be the capability to deploy an antivirus on a PLC. So the capabilities to secure that through certain security requirements may not be available. And so that is the broad concept, again, of security levels. Then as we start to think about, all right, what are we going to do to help achieve said security level? We have a set of foundational requirements, of which there are 7. And we'll talk more about what those are, but those are essentially those foundational elements that form the foundation of security. And then within each of those FRs, as it were, there are SRs, security requirements. And an FR may have multiple security requirements, and then those security requirements in themselves may have enhancements or REs that get into more detail. At the end of the day, the notion here is to try to break up the system, the overall process, into a set of systems that can be prioritized based on risk, based on potential consequence, and then set security levels based on those, and then eventually achieve those security levels over time by implementing a set of security requirements. Again, this is not intended to be a whole course on all the details of 62443, but it's important to set the stage. And then the way we think about approaching how we get there is like most of the life cycle models out there, right? And if you were doing this against the NIST CSF, you would typically take a similar kind of approach. The first would be to identify the endpoints and the network connections, et cetera. So build your visibility, asset inventory, whatever terminology you'd like to use there, and then defining the zones and conduits within your environments. The next then is to assess it. And so it's to look at that environment, those assets, the groups of assets, the zones and conduits, and start to assess the risks, both the likelihood as well as the potential consequences of an event. And then the designing the remediation plan, the controls, et cetera, that you can take, or in the IEC vernacular, the security requirements that you could take to help improve your overall security level actuals. And then it's about actually implementing them, right? Deploying those SRs, those security requirements, to begin to achieve a higher level of security level achieved. And then finally maintaining, and oftentimes this gets forgotten in these discussions, but one of the biggest challenges in ICS security is what we refer to as rot, meaning over time, security degrades. Backups don't get updated the way they're supposed to. Configurations get changed in networking devices, or ports get opened in devices that shouldn't be, et cetera. And so being able to monitor those changes and being able to maintain resetting those security levels, security requirements, so you can maintain your security levels is critical. One of the biggest things that when we see clients who have gone and tried to implement this in a manual fashion is over time, it just degrades. So anyway, this is the basic process that one would go through. And it can take a while depending on the approach. So how does that start? Well, that starts with this inventory. It starts with being able to do identification. One of the things we often hear is, well, how would we possibly gather all this data? Well, the key is getting down into the detail of those assets and the endpoints. So getting down assets all the way through backplanes and out the back end of the backplanes, getting network connections and shares, flows. Importantly, because of the conduits notion here of being able to protect those conduits, is the network device configurations and rule sets themselves. So it's not just enough to know that two devices are communicating, but one has to understand, is it possible for them to communicate? Meaning, what's the rule set hiding in that switch, firewall, et cetera? And then down to patch status, vulnerability information, password settings, accounts and users. One of the things that we regularly find when we do these assessments is dozens and dozens of dormant accounts, or accounts with outdated passwords, et cetera. Accounts that may have been created for an outage for a vendor, and they still are there 2 years later. And so those are creating risks in the environment. So having that deep visibility allows us to start to begin to take this approach and move through the assessment. So in that definition of that identification period, it is then important to identify our zones and our conduits. So to group our cyber assets in groupings that need to communicate with one another, and then naturally group those based on overall security levels required, based on the risks that that system may pose to the overall process or to safety. And oftentimes these get structured by function, but that's not always the case. It really is dependent on that particular process. And then defining the conduits. So the logical grouping of communication channels between zones, essentially the cyber assets and protocols that enable one zone to talk with another zone. Key, important that we're not having, 4 or 5 zones talking with one another, but zone to zone. And then again, it's intended as a way to define those security levels. So as we do the identification piece, we want to sort of group these assets into zones and conduits, which then allows us to build our security levels against those zones and conduits. So what is an SL? What is a security level? So there's values between 1 and 4. We're not going to go through all the details of that today, definitely available on the ISA websites. But basically there are 3 of these components. There is the desired security level or the target for that zone or conduit or that individual asset. What is the security level that we want to achieve for that? Then there's the capability, meaning when it's properly configured, what is it possible of achieving? It may not be possible on certain devices to achieve the level that you can on another device. And then finally, what is the actual achieved level? And there's 2 parts to this, right? There's the assessment part. So we want to assess to see where are we today? What have we achieved already, right? Because in many cases, OEMs have put in solutions into their products that provide a certain level of security out of the bat, right? So there may be antivirus, there may be ports that are shut down and disabled, et cetera. So understanding that achieved security level to start with, and then how we're going to move from current achieved towards our target. FRs, so these foundational requirements, we're going to talk more about these on a specific HMI example of how do you build the foundational requirements for a particular endpoint. But the notion here is a set of 7 basic requirements. And again, there's no perfect, somebody could argue there should be an 8th or there should only be 6, but this is how the IEC 62443 has established them around identification, use control, integrity, et cetera, timely response, et cetera. And these foundational requirements essentially are acting as the way that we're going to be able to improve the overall security levels. And then each of those foundational requirements will have n number of security requirements. So it could be that the foundational requirement 6 might have a security requirement of having audit logs, and then you might have a further requirement enhancement of programmatic access to those logs. And so what it's doing essentially is walking you through a stair step from these foundational requirements, then at the next level of detail, the SRs, and then the REs. And it's a very, not surprisingly, because it's engineering driven, a very well structured, broken down process to get you there. And so that stair step, we like to say that to IEC Nirvana, IEC 62443 Nirvana, is to assess that risk by zone or conduit, then to choose a specific security level target, then to iterate through the foundational requirements and the related security requirements. And based on the security requirements and any enhancements, then to arrive eventually in SLT and an SLA that is greater or equal to your SLT. I mean, the process is very, very logical. It's a very stair-step kind of approach. It sounds really simple. However, the reality is often quite different from that simple stair-step. And so, as one of our colleagues likes to say, but reality bites. It is tough because you look at this and it seems like it makes all the sense in the world, but then these challenges hit. And there are probably 100 of these challenges. We've just tried to put our top 10 list together based on what we've seen when we meet clients for the first time. So great, we want to do this zones and conduits thing, but we have no visibility. And now we're going to spend the next 18 months trying to get visibility and asset lists and et cetera, et cetera. We are trying to conduct a cyber PHA, which is the physical hazard assessment, which is a great process, by the way. It really goes into detail, but it can be really expensive and often lengthy, because if you've got 60 plants around the world, trying to do one of those at each site can be quite time consuming. And so now we start to add budgets and those kinds of things. Then we say, okay, now I've got to establish these targets, right? These SLTs and the requirements for each zone. Well, what we often find is this leads to a lot of debate and frankly, not a lot of progress, right? A lot of paralysis by analysis kind of thing. Managing all these requirements across multiple or dozens or hundreds, depending on your organization, it becomes overwhelming. In many cases, what we find is a client will have, at one plant, they'll have an OEM that put in a security set of tools or something, right? And they're trying to achieve certain standards. And then at another site, they've got other tools. And they're trying to manage these multiple different OEM tools at multiple sites, and it becomes overwhelming. There's the talent problem. There's the organizational challenges of IT saying, well, we should do this, and process control saying, well, you can't do that. How do we judge and bring those people together? There's outage limits and resourcing challenges. We've been doing the Purdue Model for the last 5 or 10 years, and we're frankly just pulling our hair out trying to get that done. And now you want to add this whole new one on. So there's just a lot of challenges when we typically will first encounter an organization trying to go through this. And by the way, all well-intentioned, all trying to get to the same good place, but it is challenging. And so this leads to a number of the questions, I think, that we got before this webinar. So we got probably 50 or so questions before, and there were things like, how does all these different standards fit together? Somebody's telling me I should do NIST CSF, and someone else saying IEC 62443, and how do I work all of this out? Where do I start? How do I do this? How do I find a balance of what's the ROI between a higher level target and the cost? Can I automate this? Because if not, I just don't have the resources to pull it off, et cetera. So there's a number of questions, and we'll try and touch on these questions. We tried to design the webinar a little bit to touch on some of these questions as we go, some of which we've already obviously touched on as we've been talking here. So what do we do about this? What do we do about this great framework, great standard, but challenging implementation? And so our view is really ensuring that we don't let perfect be the enemy of the good. So there is a better, perfect is tough, right? There is no perfect in security given the threat evolutions. But, what IEC 62443 is taking you on a journey towards a much more secure and frankly risk-based security approach with specific risk cases, multivariable attack patterns, customized risk perspective for individual products, processes, plants, zones, et cetera, customized targets, et cetera. Given the above challenges, what we have found is to try to make practical progress and to, as I said, not crawl, walk, run, sprint our way to improve security. So first, ensuring that we're starting to make progress without 12 to 18 months of planning and debate about what should be the biggest risks or what should be the SLTs, et cetera. Secondly, automate. Using some form of tech enablement to get a comprehensive, what we call a 360-degree view of your risks, and then apply not just perhaps the security requirement that seems most obvious to do, like for instance, patching, because you may not be able to patch a controller. So thinking about the compensating controls and using the tech-enabled approach so that you can balance those different mitigations. Consider both network and endpoint. A lot of times we see people run down the road of network protections. Well, we're going to segment everything, which, by the way, is great. It's a terrific security. The problem is that many times that means, okay, now I got to find hardware. I'm not sure anybody's tried to get Cisco hardware these days, but getting an FTD firewall is pretty challenging. but and then you have to get, you've got outages you have to take, et cetera. However, endpoint security, while not as much focused on in the ICS world, can actually be faster in some cases, because you don't need additional hardware. You don't need to shut down the plants. There are ways to get this done in a more efficient way. So thinking about both of those, not one or the other, and then focusing on those biggest threats first. The notion of ransomware right now has become the cause celeb in our cybersecurity world. We'll talk a little bit more about that as we go, but thinking about how do I focus on those biggest risks across the board, not just the biggest risks in that site, but the biggest risks across the board first. So the first part about this, how do we start to make some progress? What we have found to be effective is to leverage a technology-enabled approach to do this, to automate the approach, and to be able to do that in a way that you can gather back not just the asset inventory, although that's very important, but a deep view of the risks of those assets, the vulnerabilities that are involved, the patches that are missing, looking at the configuration settings on all those assets to see, are they set securely, whether that be against a standard like DSysTig or CIS, or frankly, against more, known good, I'll call it, in some of the OT devices. Users and account risks, as I mentioned before, lots of times those are big risks, and being able to balance those and see those risks in that inventory. Anti-malware status, are we up to date? If we have anti-malware, even up to date with it, right? It's great we have a McAfee or Symantec on that endpoint because it came with the vendor's deployment, but it hasn't been updated in a year. Network protections, do we have any form of network protections? As I said before, what are those firewalls and switch rule sets that are in place? Are we actually protecting VLANs and communications from crossing where they shouldn't be? Backup status, do we have backups at all? And if we do, how up to date are they? And then finally, asset criticality. And this is something that we've found we can leverage a lot from prior work in DR efforts that our clients have gone through, or we can create we can create asset criticality based on that 360-degree view of the asset, based on what it's talking to, based on what the asset is, based on the part of the process that it's managing. So in short, this 360 approach allows us to avoid all the manual process, which takes a lot of time, and to see all those risks, to start to be able to allow us to put a risk score to the asset and then make trade-offs of what's the most efficient way to secure it. So just as a comparison, right, if we take the notion of an SLT, like a target for that security level, it's great, we should have that. But then what this allows you to do is to say, okay, I may not be able to hit that target, but what's the most effective way of securing that asset? What mitigating controls are the most effective way to reduce the risk score of that asset or that zone, et cetera. So that's sort of the initial part of trying to make progress. One of the things people often talk about is, well, I'll try and use my network-based visibility to do this. And we often find that falls short, that the network data is helpful, don't get me wrong, but it's hard to know much more than, okay, so it's a Windows box or it's a PLC, but when you get down to actual patches, like all of the detailed patches deployed, or the policies, or the users and accounts, the purpose of that device, et cetera. And if you don't get the actual conduit rule sets, meaning the network device rule sets, and all you know is the actual traffic passing, it's hard to know if that is, if there are allowed traffic that just hasn't occurred yet, et cetera. And so as we take this tech-enabled approach, our strong recommendation is to have an endpoint-based view of this inventory as a way to start. That visibility then, and Ryan will show you how this comes to life, that visibility then allows you to start to see where your status is against various SLs. So, your actual SL is against various security requirements. So vulnerabilities, right? Patching vulnerabilities or remediating vulnerabilities. And so by enabling this, by using this tech-enabled approach, we can then quickly gather these vulnerabilities in an automated way, right? We know we can't scan an OT network, right? You can't run a traditional IT scanner because you're going to knock over the plant or at least certain devices. And so by using that endpoint inventory and then automating that connection with the known vulnerabilities out there, we can start to see what our security level actually is against that particular security requirement. Similar story for admin accounts or accounts overall and users. So do we have a lot of admin accounts with expired passwords? Do we have inactive accounts out there? And again, that allows us to find this richer view of what are the real risks to that zone or that conduit. Getting all the way down to the patch levels, right? So one of the things that's really challenging is actually knowing exactly what patches are missing, right? It's not just enough to know that, oh, it's running a certain version of OS. No, there are individual patches you need to break down to understand what vulnerabilities are being addressed. And then finally, configs, right? Understanding, are the configurations that we have on these devices, are they set in a way that is secure? Are they compliant with various standards? These may be internal standards that your organization has, maybe IT standards that they want to port over and you can mold to the OT environment. But the point is that being able to get that view in one place allows us to, in a much more efficient way, help clients define the SLAs that they're at and then over time maintain them. So I said earlier, one of the keys to this is also being able to focus on those greatest threat vectors. Again, every organization is going to have their own. We're not saying that ransomware is the only threat out there by any means. However, again, the SANS survey done over the last 6 years or so, tells an interesting story about where at least the industry thinks the greatest threat vectors are. And obviously, ransomware has moved dramatically over the last couple of years from being, frankly, an also ran when it comes to threats to being, by far the most significant threat. And so as we think about defining, how do we get started, right? Not to say that ransomware is the only threat vector you want to think about, but as we think about how can we make progress in a rapid fashion, how do we get the wheel spinning? Well, one of the ways is we can focus on these bigger threats. And so starting with ransomware, okay, how would we go at trying to protect ourselves from ransomware? And so one of the keys to that as an example, and we're using this as an example of how this might come to play, is looking at the foundational requirements for a typical Windows HMI server workstation within the ICS environment, right? So how does ransomware begin? Well, so far, anyway, all of the ransomware that has been used in actual public attacks has come through the traditional OS type devices. While there is a lot of proofs of concept of ransomware on PLCs, et cetera, and that may happen here very soon, obviously the biggest risk these days is around these HMI servers workstations from a ransomware point of view. And so then what this is doing, just is just walking around the various foundational requirements so that we can see what are the various security requirements or foundational security requirements within those foundational requirements that we could implement, whether it be user and account management at the identification of a foundational requirement, or in system integrity, deploying application whitelisting and patching devices, et cetera. Or in timely response to events, do I have SIM alerts? Am I able to take rapid response actions if something actually were to happen? Can I, on availability, do I have updated backups? And again, that tech-enabled view allows us to see, okay, how am I doing against these? Am I actually achieving that foundational requirement or not? And then as we move from that priority and thinking about what are my risks on the left-hand side, then having that technology platform in place also allows me to start to take actions quickly against those risks. So one of the things that we often hear is, well, okay, we spent X number of months trying to define our security levels. We then spent Y amount of months assessing and then Z getting a design in place, and now we're about ready to start implementing more security. And we're now 18 months down the road. And so one of the things that we find to be very helpful is whatever technology platform you're using to be able to do your assessments is also able to take the remediating action, meaning not just knowing that you've got a vulnerability, but being able to patch it, as this chart shows here, or being able to harden a configuration, being able to manage users and accounts, being able to, to ensure backups are up to date. To be able to take action to remediate those risks immediately really accelerates this, right? So I'm not now 18 months starting to try to take actions, but literally the minute I've assessed, I can start to take remediating actions at that site. And so it accelerates the time period with which we can start to achieve those security level targets, which we set originally. Next, so okay, now I've assessed it, I have started to remediate it, but then the rot starts to happen, right? That, okay, great, I did a manual assessment, I then manually made changes, or I put in a network segmentation, et cetera, but then over time changes happen. And so one of the keys to however you go at this is to be able to monitor the system on a real-time basis for any changes that might change your security level actuals. So backups that failed, new vulnerabilities that are released, or patches that are released, and knowing if they're applicable to that device. Changes to configuration settings, so a port gets opened, a rule gets changed in a switch or a firewall, new accounts get added, et cetera. And one of the things we see often is well, we had log collection, but at some point it stopped and we weren't really paying attention, we didn't get an alert. The point is that being able to monitor these allows us to keep those security levels up. And while we certainly want to improve, we want to move our targets higher, we want to move our actuals higher. One of the things we really want to do is make sure that those actuals don't dip once we've achieved a certain level. And key to that, at least in our view, has been having that technology-enabled platform to do that. And so, these are the kinds of risks that you might be monitoring to see if things have changed, whether that be, identifying new accounts up at that kind of 1 o'clock, down at 6 o'clock, ensuring backups of a server in your SCADA system, identifying new vulnerabilities on your servers, or alternatively, down at 5 o'clock, they're identifying new wireless devices that get added to a backplane. One of the things we find often is, somebody's trying to do an IoT initiative and they plug in a cellular enabled device into the backplane of a controller or a PLC, and next thing you know, you bridge the internet with your control systems. So being able to identify that and then quickly remediate it. These are just some examples of the kinds of things, and obviously we'll be sharing the deck later. And so what we have found is one of the keys to this is to bring these pieces into what we call an OT security management or OT systems management platform. So first, the ability to have all of that inventory and then the individual components that we're talking about from a security requirements or foundational requirements all integrate into a platform. So we don't have, well, we've got a visibility from one plant over here, or we've got all of our Rockwell stuff over here, but that's separate from our Yokogawa stuff, which is separate from our Honeywell stuff. But to have a single OT platform that crosses all your vendors, that crosses all your security requirements, so that you can have visibility. And then the ability with that platform to take action. So not an IT tool. We know that IT tools have challenges in the OT space, but to have similar kinds of capabilities to manage that security level of that device on an ongoing basis. Important that this integrates with the IT security tools. So one of the questions that came up prior to our event here today, our webinar today, was, okay, well, great, I have an OT view, but what's my IT view? And can I have a single pane of glass, so to speak? And our view is that to get that single pane of glass, we got to start with an OT single pane of glass, and then that can integrate with the IT's pane of glass. So for instance, it can integrate with your ServiceNow, your Splunk, whatever it happens to be, so that you can bring all of your OT data into a single view with your IT data, and you can start to manage those together. Without an OT security management platform, it's impossible to try and integrate, dozens of plants or vendor systems or whatever into one overall IT stack as well. So with that, I'm going to hand it to Ryan for a few minutes just to show you how this notion comes to life, so you can see how different zones, for instance, will have different security levels achieved and how you can monitor that. So Ryan, I'll hand it over to you.
Sure, thanks, John. Let me get my screen shared out here. Hopefully everybody can see that okay.
Yep, it's all good, Ryan.
Great, okay.
Good size too.
All right, perfect. All right, guys. So to start this journey down IEC 62443, it all, really depends on having a sound and robust asset inventory. And so before we kind of dig into showing you the differences between zones that are, have met their SLTs and ones that are still progressing to that pattern or to that approach, I just want to show you what kind of data, is useful to have in here. So looking through what's in here, being able to map things like control function per region or per plant site, looking at, the different manufacturers, depending on different processes you have. So, this is modeled after, in this case, around a paper plant, but looking at the different cycles and processes and what types of vendors are out there in those environments. And I will mention, this is covering not just Windows, but you can see things like ABB, GE Fanuc, Landis and Gear. Those are all traditional OT type devices that are, that are in here, not just the Windows-based things. So when we scroll down here a little bit farther, this is where we start to see the zones. So these are the different zones of IEC 62443 in our environment here. We have A through D in our lab here, as well as, and this is the counts of assets in those environments, as well as, impacts these assets have in the environment. So how impactful are they? But kind of building on top of that is determining risk, looking for how is this asset a risk to our environment, looking at things like, expired user accounts, services that are running that are knownly insecure, patch status, those types of values can all come into play. And this is something that with our platform is customizable, right? We do include out of the box an algorithm to use, but it is definitely customizable by the end user to where they can take into account different metrics about assets. And then finally, kind of around conduits as well as the zones, but also making sure that we don't have assets that have more than one IP address or multi-homed across different conduits or different zones. So making sure we detect and investigate those when they are discovered. So going into more of the 62443 items, what I want to bring up here is some vulnerability data. And so just looking through this, there are things like severity, attack complexity score, availability impact, those types of metrics around vulnerabilities. But to compare this to IEC 62443, let's look at, for example, Zone A here. So Zone A has met its SLTs. And so we have noticed there are no critical vulnerabilities in here anymore, which is the initial target. And so now we can start looking at going after high, medium, low severity vulnerabilities that are less impactful in our environment and pose a less of a risk. Now, if we compare that to something like, let me disable this one and go back to the Zone B here, which is has yet to meet the SLT. You can see that there are actually 27 critical vulnerabilities, as well as an extraordinary amount of high vulnerabilities that we should probably, to at least try to get down in this case, as well as a very exposed asset here with a high exposure score. And just to add in here, when we start looking at these different zones, I'm actually going to enable a filter here I built while John was talking, but this is actually bringing out vulnerabilities in OT equipment specifically, not just Windows assets, but these can also be taken into account with your zones. So for example, looking at things like networking gear, controllers, PLCs, relays, other types of OT devices that are out there in the field. So as we go into, for example, users, so we see this as actually a kind of a missed opportunity of a lot of our customers, where they focus more on the hard security like vulnerabilities and configuration, but they don't take into account things like users. and which do play a significant risk when it comes to making sure passwords are changed, as well as looking for any dormant accounts that exist out there in the environment. So that's what this particular dashboard is really bringing to light is, here's a list of expired, users with passwords that are older than 180 days. Same thing with, hey, how long has it been since users have logged in? These are all older than 180 days, and as well as administrative privilege and if they are local or domain accounts. And so kind of along the similar fashion, if I want to bring up, for example, the Zone A that again has met its SLT, we can see that we have reviewed all accounts with expired passwords. We have changed them where we can, as well as made sure that there are no dormant accounts floating around out there. And if they are, they're at least tracked and maintained to make sure that they are protected. And then similarly, if I actually go back to the Zone B, we will see that there are 11 instances of the administrator account that has an expired password. So I filter down to that administrative account, and down here at the bottom, we'll actually see our list of endpoints that have an administrative account or administrator account with a password that has not been changed in 180 days. Now, kind of to talk more about configuration hardening. So this is, a side of vulnerability risk is, making sure assets are configured in a hardened manner, whether it be to a specific standard or just, generalized hardening critiques or metrics. It is also a good idea to investigate these. So for example, things like making sure that you have deny any-any's in your firewalls, making sure that you're disabling guest accounts and renaming administrator accounts and other types of policy settings you might set on a Windows endpoint as well. And so we can go, kind of along the same pattern here. So if we look at a Zone A, for example, is making sure that we have all of these set to our standard or to our SLT, and then monitoring this for changes. So getting alerts when we may go away or stray away from our target to make sure we go back and remediate any of those issues. And then also using that same data to, if we look at the one that hasn't achieved SLT, we can actually go and see where we can start, making some impact on this. Where should we start first for the least amount of impact to try to get this to our target of being 100% compliant. And then again, using this data to audit where we are in that process. Last but not least, I can also bring up patching since we did talk about vulnerabilities. So obviously patching is directly related to that. So really along the same lines is using this data to kind of audit how we are doing with, getting to our SLTs and maintaining those SLTs. And so again, looking at the different severities of applicable patches per region, or we can do this by zone as well. So we can look at different zones. Release quarter of patches, how many patches do I have outstanding, when were they released, are there really old patches like this one floating out here that's from 2003, and then also looking at metrics like which is our asset that has the most missing patches, is it a risky asset, what kind of vulnerabilities does it have. These are all things that can be taken into account when we start looking at making sure we're meeting those targets. So just for the sake of repetition here, I'll just show you real quickly Zone A. So we can see that there are no critical patches. There still are some missing patches, but none of them are in the critical range. There are mostly important in this case, which are still something that we should take advantage of, but it could have been the first phase of reaching that SLT, is getting rid of those critical patches. And so obviously you can probably assume when we look at Zone B here in this case, we will actually see that it is much worse off than the other side. So we have lots of critical, missing 102 of those out there, 1,000 total patches, of much larger swath of release dates that are still applicable. So there's a lot of room to go, but also using this to again audit where we are in that process. All right, John, you may throw it to you for questions or.
Perfect. Thanks, Ryan.
Yep.
Appreciate it. So, and I know there are a number of questions here, and I want to make sure we address a bunch of those questions here today. I'm going to quickly share my screen for a second, and then So we're going to talk, our next webinar is going to dive deeper into the overall governance and organization. A lot of the questions prior to the conversation today were around that. Just going to tease that bit with this approach allows you to do what we call think global, but act local. So in other words, to scale this analysis across sites, vendors, et cetera, into that dashboard you're seeing, and someone asked, is it cloud-based? it can be cloud. Most of our clients are deploying this on-prem because they want that data not to be shared in the cloud. Like I said, we came out of a NERC SIP world, which is not even allowed to share that data in the cloud. And so, but it's cloud enabled, so it's certainly able to be done on the cloud. But the point is to be able to scale that centrally, so a smaller group, smaller team can be looking across those sites. It's going to be impossible to achieve an IEC 62443 maturity if you're essentially relying on every site to have its own, security personnel. And then the notion of act locally. So we can gather all this data centrally, but then when it's time to take actions, it's critical that those actions are controlled by operators. So one of the questions in the chat here or in the Q&A was, well, how do I, for instance, on patching, how do I make sure I can validate those patches before they're deployed? Or alternatively, questions around, what can I do to take an action at a site that if I can't disrupt that asset, meaning I've got, 100% run times, I'm running 24/7, how do I actually take any security actions? Well, what a platform approach like this does allows you to think globally, scale, et cetera. But then when those actions happen, they're controlled locally by the plant or the site personnel or the functional personnel that know that process. So before any action is taken, whether that be a patch deployed or a configuration hardening or anything, the engineers at the site or the OT personnel, and it may not be at a site, to be fair, it may be regional. These may be multiple sites that are run, as a single entity. Those actions are then controlled locally. They're automated, meaning it's not like I go around to each machine with a USB stick, but they're controlled locally. So I can know when I can do it. Is there an outage? Does this action require an outage? I can actually set it so that the action won't actually take until I reboot the machine manually rather than automatically. A whole set of capabilities there around designing that. But the point is that there are a lot of things we can do to secure these systems without an outage, right? We can harden configs, we can manage users and accounts, we can manage backups, we can frankly harden firewall rules and switch configs. We can deploy application whitelisting and USB lockdowns. All sorts of things we can do that don't require a reboot of a machine, which can significantly add to those to the overall security level achieved. So with that, I'm going to try and address a few of the questions that came in. One of the questions was around how many zones. Unfortunately, there is no right answer to that question. We've seen organizations where they may have, 3 or 4. So in a typical power plant, maybe 3 or 4 zones. But we've seen others where there's a dozen. And obviously then if you multiply that across sites, et cetera, it changes. Now, one of the things that we found to be quite successful to get started, again, not the end state, but to get started, is what some of our clients have done has said, okay, look, we're going to have 4 broad categories of zones. Every asset in every plant has to fit into one of these 4 broad zones, and similarly, or conduits. And therefore, what they can do is then accelerate the process of defining zones so they don't end up in, paralysis by analysis of every single plant is defining their own zones. Another client of ours said, frankly, as we get started on this journey, we're not going to do different zones. We're going to assume everything inside the DMZ is the same zone. And so we are going to treat every asset in that environment to be the same in terms of its security requirements. And we are going to apply a certain standard to every asset to get started. It radically simplified the implementation. Now, obviously, doing that, they're going to waste some cost and time because they're going to execute security requirements on certain assets that may not be necessary. But their decision was actually it's going to cost us more in time and energy to try and get this perfectly defined than it will be if we just set one standard and move from there, and then we'll refine once we've made security improvements. One of the question is, was here, what's the best quick wins? And there were some great answers listed in the Q&A here or the chat there after that question. One thing we'd encourage is one of the quickest wins you can do is is response and recovery. And so there was a point about awareness. Awareness is key, but one of the things that we think is one of the fastest things you can do is to ensure that you can recover quickly in the case of an event. Okay, how do I do that? Well, I know what I have, right? It's relatively quick to get out there and deploy something that allows you to see your inventory and your assets, and then to be able to know if you got a backup for those things. Backups are, they're worth their weight in gold. And so often we find that people have a backup program, but that backup program is maybe not as up to date as people thought. Another question that came in before is, one of the other questions in here was some comparison of different tools. Look, our goal today is not to try to sell Verve, and we could spend a lot more time if that was what we were trying to do here. And we'd be welcome to that conversation. What we're trying to do is to lay out a concept of how this could work. I'm sure there are multiple tools. We can talk exactly how Verve does this. We've shown you a little bit of that. If someone would like to have more information, please do reach out. We'd love to talk more about it, but we also want to be careful that these are intentionally meant to be educational rather than trying to compare Verve versus other tools. Lastly, one of the questions was around ISO 27001 and how that compares. ISO 27001 is a great standard, but it's not specifically an OT standard. And two, it is going to be more what I'll refer to as procedural than it will be in terms of having specific controls in place. And so while, again, many people are combining these, right? We have a lot of clients who are doing 27001 while they're implementing parts of IEC 62443. It's a great thing. It also can be audited, which is a really important thing for certain organizations. But it's certainly not a replacement for the IEC 62443 standards. If we have to provide a cloud service for OT, how can we adapt the standard to meet a user's cybersecurity level? So I think cloud, we should probably do a whole nother webinar around cloud and OT. There are ways to take IEC 62443 and apply it in cloud-based settings. It's the same basic concepts that work, right? There are still zones, there are still conduits. And so you're going to create different security levels for zones that need to communicate with the cloud that are communicating within a DMZ at a particular plant. And so a lot of the principles remain the same, but the execution will be different, certainly in a cloud environment. I think I'm realizing that's probably a whole topic we should cover as a separate one. I know there's other questions. We'll try and answer as many of these written as we possibly can, but I do want to be sensitive to people's time here today. So first of all, thank you all for joining us. As I mentioned, we're going to take a deep dive into governance and organization in our December webinar. We'll make sure to get that out for you. And then, as I said, we'll try and answer as many of these questions in the Q&A and chat as we can after the webinar. So again, thank you everyone for joining, and hopefully you'll join us for our December webinar as well. Thanks so much. Bye-bye.